Okay, right off the bat, guys, here we go. Right off the bat, I'd like you and your group to try out this first problem on today's notes. It says this is a regular polygon inscribed. Well, it's got four sides, and it's regular. Anybody want to give me a better definition of this figure? It's a square, yep. And I know I never mentioned it, but what is the area of a square? Length times width, and what do you know about the length and the width? They're both the same. All right, so I'm going to give you guys about 5 minutes. If it's less than that, great. The radius of this circle is 4. Can you find the area of the polygon? All right, go ahead, talk it over. There's different ways to go about this. All right, I just don't want to say do it this way. Different ways to go about this. All right, the radius is 4 of this circle. Can you find at least one side using that? All right, so let's keep going with this. All right, let me just go through what I basically saw from a lot of people. The radius is 4. Here's where I saw a lot of first. Drawing in that radius. That goes through the square, though. You'd want something probably inside the square. All right, so let's draw in another radius that's actually inside the square right here, or draw into any other vertex. New vocabulary term, not new vocabulary term, but using it differently. Everybody, this is also the radius of the square. You can have a radius in other figures other than a circle. Okay, from the center to a vertex of any polygon is called the radius of that polygon. Okay, get used to that because we're gonna be drawing a lot of them today into these polygons. From here, I saw a lot of people say, "Oh, if that's 4, well, heck, why don't I draw in another radius right there? That's 4 as well." So this whole thing here, the diameter is 8. In a square, you know there's right angles. I didn't see anybody do this, but you could have said, all right, anybody know what type of triangle that is other than isosceles and a right triangle? What's across from those congruent sides? It's a 45, 45, 90, so you could have used your rules there. All right, a lot of people chose to use Pythagorean Theorem. I also saw people draw in 2 diagonals and bisect. That's fine too. So you have x squared plus x squared equals 8 squared, excuse me. 2x squared, not x to the 4th. 2x squared equals 64. How do I get the 2 out of there? Divide by 2, I end up with 32. So x was equal to the square root of 32. So that was one side of the square. That was one side of the square. So length times width, square root of 32 times square root of 32, multiply a radical by itself, you end up with the area just being 32 square centimeters. Okay, and again, that wasn't the only way. Trust me, there was 45, 45. You could draw in the other diagonal and bisect them to form a right angle. There's a lot of different ways. What if I turn that into a regular hexagon now? How are we going to find, anybody know the formula for a hexagon? Me neither. So that's what we have to come up today. You, myself, your group, come up with different ways. Even though we don't know what the formula is for each figure, how do I still find the area? Okay, so speaking of our regular hexagon here, right? I just gave that part away. It's a hexagon. Okay, I'm going to tell you it's regular. Give me 1 second here. I got to draw in my lines. I can't see anything there. Okay. I just showed you guys with the square. What are these called now in the hexagon from the center to a vertex? They're called radius, yeah. 6 radii there. And just like a circle, what do you know about all the radii? Oh, okay. Okay, I got you. I got you. Can you also help me with another thing in your group right now? Can anybody find what each of these angles inside right here are? Can you help me find what each angle, and all these triangles are congruent. Anybody help me find what each one of those angles are? Each one of those angles, 7. Each one of those angles, 60 degrees, everyone, yep. All right, let me keep testing your geometrical knowledge here. Could you find those other 2 angles here? And remember what you told me about the radii. They're all congruent. Anybody tell me what the other angles are going to be there? Here you go, 5.
60.
Yep. Okay, what type of triangles are formed then? Good, not isosceles. You can get a little bit deeper, equilateral triangles. All right, I'm going to introduce you to a new term, a new segment up here. Everyone go to the center of that hexagon for me. Go to the center of a hexagon, and you can do this to any of the triangles. I'd like you to draw a perpendicular line down to one of the sides of the hexagon. Okay, I'm just going to take the easy way out. I'm going to draw a perpendicular line down. That perpendicular line from the center to the side, I don't know if anybody wants to have the guts to try to pronounce this, but anybody? Apothum, yes. I've heard apothem before if anybody said apothem, but it is not opossum, all right? Apothum. All right, apothum. Apothum. I just want to show you what the apothum does. It is perpendicular. And remember, these two sides were congruent. I know nobody remembers this from our triangle unit, but if you have an equilateral or an isosceles triangle and you draw what would this be considered? A nice fancy term other than a perpendicular line. From a vertice perpendicular to the opposite side. An altitude, yes. Altitude also acts as an angle bisector. Meaning, what was this whole angle here? 60. So guess what the apothum did? Just cut it into pieces of 30 and 30. And yes, that angle would be 60. It created two 30, 60, 90 triangles. Yes. Okay, so I just want you to enter, because we're going to bring this up in a second when I give you a new formula. All right, the apothum. Yeah, the apothum perpendicular to the opposite side also is an angle bisector. Oh, I got one more fact about this bad boy. Not only does it bisect the angle, bisects the sides it's drawn to, yes. All right, bisects the sides it's drawn to. All right, let's use the apothum now in these regular polygons. Take a look. Both those figures are regular. I drew some radii in, and everyone see my apothum I just drew in. This dotted line segment right here. Okay, knowing what we just did from the hexagon example, let's find angles 1, 2, 3, and 4 up here. Or actually, can you find them? Can you take 30 seconds and find them within your group right now? Go ahead. Discuss it with each other. See if you can find 1, 2, 3, or 4. And remember, the apothum bisects the angle and the sides. It may not be the same as a hexagon. That's fine. It's a square now. Okay, here you go. I'm going to start with angle 4 because I can build off angle 4. Angle 4, what'd you find for angle 4? 11. Angle 4? 90 degrees. If you're wondering how they got that, 1, 2, 3, 4 angles that all add up to 360 and they're all congruent. Okay, now going. You know that all the angles are 90. Let's go to angle 1 now. Angle 1, 17. 45. Again, why? We just learned the apothum bisects the angle of 90. All right, so I got 45 here. So let's go to angle 2 now. 18. It is also 45 because it's part of a 45, 45, 90. That's angle 2. And then finally finishing off, I didn't need to know any facts to find number 3. 1. Why? It's next to a right angle. Got it. Everyone all right? Go ahead, another 30 seconds. Number 2 now. What about the triangle? What about the triangle now on number 2? Find angle 7 the same way you found angle 4, the same way you found the initial angle in the hexagon. All right, walking around, it looks like this one was a little bit tougher. Let's start. 15, did you guys get angle 7? No? Nah, why? Okay, how did we get angle 4 here? It was 90. Because we knew we had 4 of these angles that added up to what? Okay, well, I don't have 4 now. I have, ready? 1, 2, 3 of them that add up to, okay? So 360 divided by those 3 will give me 120. Are we seeing that no matter what figure I can give you, you draw all the radii in, those angles that are formed are all congruent and add up to 360? Yes, Emily? What do you mean 180? Because how do I know all 3 angles are congruent here? Which triangle are you saying? Which triangle? The one that contains angle 7? This one right here? Yeah. Okay, how does that have any effect to... Okay, here you go. This angle 60, that angle 60, and that angle 60, I agree. But it's not one I was looking for. Okay? Okay, that's 60. Let's build now. What's got to be 5 if the apothem cuts it? 10? That's 60. Build off of that. Angle 6. 5? 30. Part of a 30, 60, 90 triangle. Questions? You guys just went through a square, a triangle, and a hexagon. How can I use one formula to find the, great. Yep. Okay, let's go. Hurry up. That's it? Curtains. Clock. I'm going assuming star. Okay. Ready? Star Promethean man. Ready? Okay, here we go. That was a clock, ladies and gentlemen. Okay, that was a clock. Okay, that was a clock. Okay, here you go. Let's get going. Any regular polygon. I don't care. All right, I don't care how many sides it has. 3, 4, 5, 6, 7, 8, 9, 10. No matter how many sides it is, here's how we're going to find the area of any regular polygon. 1/2 AP. Very simple formula. 1/2 AP. Let's see if you can bust some knowledge out here. A is something we've already talked about today. That's the apothem length. Yep. All right, P, it does start with P. Something we can find on the polygon that starts with P. Perimeter, yep. The perimeter of the polygon. All right, first one, regular pentagon. Do your best to your ability to sketch that. Regular pentagon. How many sides? 5 sides. Yep, 5 sides, regular pentagon. Do the best of your ability to sketch it. Okay, each side, 7.2 feet. And a radius of 6.1 feet. All right, so go ahead, draw yourself in a radius. 6.1 feet. What is the area of that pentagon? All right, so I see it's regular, which tells me, all right, go ahead and use 1/2 apothem times perimeter. What is one value out of these two that I can get very, very quickly? Perimeter, why? I have the side, and I know all 5 sides are the same. So the perimeter, 36. All right, now we have to work together to get the apothem length. Everyone okay on the 36 for the perimeter? 7.2 times 5. All right, what's apothem again? It's the perpendicular segment from the center, right? So go ahead. Let's draw it in. I know it's perpendicular. I need your help finding that length. Need your help finding that length. It can be done. Heaven, what are you suggesting? Say a little louder for everybody to hear. Not only does the apothem bisect the angle, it also bisects the side. Correct. So that 7.2 is going to get split in half, and I can do what? Pythagorean Theorem. Yep. So the apothem splits the side in half, so now I'm looking at, what, 3.6? Okay, what's Pythag going to look like? What's the 6.1 acting as? Hypotenuse, yep. So 6.1 squared is equal to a squared apothem plus 3.6 squared. Are we at the end of the problem when you find the apothem? No. Why do I ask that? We still need to find the area, and I asked that because we're not rounding the apothem. You guys are getting what? Square root of 24.25? Taking the square root of 24.25? That's your apothem length? .6 square feet. I don't want to go to the next one, though. I want to stay right here. Because when there's the opportunity, I don't just want to say, do it this way and no more discussion. Would there be another way without using that formula to find the area of that pentagon? And let me help you guys out. Would there be another way without using that formula to find the area of that pentagon? What do you got for me, Will? Do you guys know the area formula for this figure? What's the area formula for a triangle? What would be your base then? Height we just found. There's the area for one triangle, and then you would take that and multiply by. Okay. Okay, so if you forgot, all of a sudden you forgot 1/2 AP or just don't care to use it, you can always cut it up into congruent triangles, find the area of one triangle, and multiply by how many there are. Okay? Questions? All right, I'm going to do one more with you, and then I'm going to let you do the two in your group. Good. Yep, you got it again. Anything else? Okay, ready? Genie? Cube. Page curl. Oh, we have cubes. Page curl. Curtains. Page curl next. Curtains. Star. Clock. Pinwheel. Okay, pinwheel. Ready? Pinwheels. Okay, everyone ready? Pinwheels or Promethean man? Ready? Here we go. Pinwheels or Promethean man? Ready? Ooh. Okay. Great. Let's go. Okay, find the area of this equilateral triangle. Equilateral, does that means it's regular, correct? Okay, it's regular. Now, I'm going to show you 1/2 AP. Could you get away with doing 1/2 base times height if you knew the base and the height? Yeah. Okay, that's fine. All right, here's the problem with this one, though. Do you know the apothem? Nope. Do I know a side length to get the perimeter? Nope. So we are on our own right now. All right, let's start. Let's draw our apothem in. Or apothem. Apothem or apothem. Either one. Okay, I know that forms a right angle when I draw it down because the apothem is perpendicular. Ooh, do I know any other angles? Hey, real quickly. Hold on. The apothem is splitting what angle in half? Anybody remember? This full angle? Oh, come on now. This whole angle was 360 divided by 3, so that was 120 degrees right there, right? So the apothem's breaking it up into a 60. Everyone okay where that 60 is coming from? Splitting the 120 up. So that must mean the other angle in that triangle is going to be, and I think we know some rules about that triangle. Where's the 4 across from? 90. All right, let's think about our chart. Write it down if you need to. If the side across from 90 is 4, what would be the side across from 30? 19? 2. And Kate, you just found our what? You just found our apothem, 2. Okay, what about the side across from 60? Anybody know what that missing side's going to be using your rules? 15? What do you do? The side across 2 square root of 3. All right, I'm going to need everybody's help now. How do you use that piece to get to the full perimeter now? Amy? Okay, I'm listening. Okay, and that'll get this piece, right? Because that bisects. Anybody know how long this side is now? 2 radical 3 plus 2 radical 3. 4 radical 3. 4 radical 3. Yep. Perimeter. If you add up all those radical 3s, how many do you have? 12 radical 3. Anybody take a peek up at the directions? Simplest radical form, which means get that radical 3 down in your answer, please. And with the radical 3 down there, 1/2 times 2 times 12, we end up with an area of 13, area of 11. 12 radical 3. And no units, right? Nope. Okay, you have no homework. You can give me time to grind out 5 and 6 right now as I come and sit with every group. All right, go get to 5 and 6 right now. If you rather split it up into triangles and find the area of one triangle, that's fine. If you rather use 1/2 AP, go ahead. Coming right over, Emily.